All right, so we're going to talk about the polarizers. Now, polarizers actually have operate on different principles. Meanwhile, what are polarizers? Polarizers are objects or like materials that actually cause light to move in a certain plane. Are we together now? So that's polarization. It causes polarization. So polarizers actually work on different principles. We have polarizers that work by reflection. We have polarizers that work by selective absorption. We have polarizers that work by double refraction, and we have those that work by the scattering of light. And when it comes to polarizers can produce two different types, or we have two different types of polarizers. We have the linear polarizers and we have the circular polarizers. What does it bring to mind? Linear polarizers actually lead to the production of plain or linearly polarized light, while circular polarizers are polarizers that lead to the production of circularly polarized lights, which we have under the types of polarized lights. So let us look at the linear polarizers type and the circular polarizers, their types, and then we can now make progress to the types of polarized lights. So for the linear polarizers, we have absorptive polarizers and we have beam splitting polarizers. Beam splitting polarizers can also be called double beam polarizers. Can also be called double beam polarizers. So we have absorptive polarizers and we have beam splitting polarizers. Now for the absorptive polarizers, a very good example is the Polaroid, and the Polaroid is made of polyvinyl alcohol with an iodine doping. How does this one work? The absorptive polarizers here work by absorption of every other light that is not on the plane of polarization. When we were dealing with the polarized light earlier on, we had a light that was moving in different directions. We had lights that was moving in different directions, like your sunlight, your bulb, and other type of light. And then we had a polarizer, and then you have a polarized light that is moving in one direction. In absorptive polarizer simply, what absorptive polarizer simply does is that it absorbs other lights that are not in the particular plane it wants to project. So it absorbs the others, and the one that it wants to project is what now passes through. That is the principle for absorptive polarizers. While for beam splitting polarizer, which is a good example, is the nickel prism. Or we have the nickel prism, we have the quartz, and we have the Yellowstone prism. So those are the three examples we have. We have the nickel prism, we have the quartz, and we have the Yellowstone prism, which we call double beam. Why do we call it beam splitting or double beam? It's because in this case, it splits the light into opposite directions. Like what we have there now, we now have the polarization occurring in two different directions. So they are the same polarized light, but are just operating in two different directions. So any of the lights you choose to use, it is already polarized by reason of beam splitting. So the nickel prism is made up of calcite. Calcite is a form of calcium triazocarbonate 4, which is limestone, which is a refrigerant crystal. Another example of refrigerant crystal is quartz. Another example is Yellowstone prism. All of these things operate on the principle of beam splitting, and the type of light that two of them produce is the linear polarized light. Then for the circular polarizers, we have the quarter wave plate and we have the half wave plate. Now for circular polarized light, polarizers actually produce circularly polarized light. That is light that is rotating. It is not straight, it is rotating in a particular direction. So it can be right-handed, it can be rotating this way, and it can be left-handed, it can be rotating this way. So this is clockwise or right-handed or rectus. Do you remember that? And then this is left-handed or anti-clockwise or sinister, S, which we talked about at the beginning. So if it is rotating right, we call it right circularly polarized light, and if it's rotating left, we call it left circularly polarized light. So that shows chirality in a way. And then for it to be able to produce such kind of light, what we simply use is the quarter wave plate. So this is how it works. First of all, the light is transformed into a linear polarized light, a plane polarized light, first of all. Then after it has been converted to a plane polarized light, it is now passed through a quarter wave plate. So this is going to be a linear polarizer. For example, let's say a Polaroid. Which is an example of a linear polarized light. And then this is now going to be a quarter wave plate. A quarter wave plates. So when it passes through this quarter wave plate, you now begin to have lights that are rotating. I don't know if you're getting it now. So first of all, you get a linearly polarized light, and then you now pass it through a quarter wave plate, and it produces circularly polarized light. If you choose that you want to convert circularly polarized light back to linearly polarized light, you still get to pass it through quarter wave plate. So quarter wave plates can convert linearly polarized light to circularly polarized light, and convert circularly polarized light back to linearly polarized light. But then when it produces a circularly polarized light, it can either be right-handed or it can be left-handed. So if you want to begin to convert from right hand to left hand, from left hand to right hand, what you're going to use is the half wave plate. So the half wave plate is used to convert right-handed circularly polarized light into left-handed circularly polarized light, and vice versa, which means you can also convert left-handed circularly polarized light into right-handed circularly polarized light. So why this one converts linear to circular and vice versa, this one converts right-handed circularly to left-handed and vice versa. So that's not about the circular polarizers. So we're now moving over to the types of polarized light. We have three types of polarized light. We have the plane or linearly polarized light, we have the circularly polarized light, and we have the elliptically polarized light. Now for the linearly polarized light, which is the plane polarized light, what we actually have there is the light is vibrating in one plane in one direction, in one plane in one direction, and according to analysis, it is almost looking like we have a right circularly polarized light interfacing with a left circularly polarized light to give a plane polarized light. So all we have here is what? Right circularly polarized light interacting with left circularly polarized light to produce a plane polarized light. So that's what leads to the linearly polarized light. So they are both working together in synergy as right and left-handed, and it gives a plane polarized light. Where do we use linearly polarized light in? We use it in polarimeter to measure rotation, to measure optical rotation. Polarimeter, we're going to look at that in our next discourse. So we use it in polarimeters for measurement, or we also use it for measurement of specific optical rotation, and we use it for optical rotatory dispersion, ORD. While for circularly polarized light, circularly polarized light is a light where the electric field of the passing wave changes direction in a circularly or rotary manner, but the strength remains the same. In circularly polarized light, the strength of the wave is the same, but then the direction of the movement is constantly changing in a circularly manner. Remember, in linearly polarized light, it is a single direction, but in circularly polarized light, it is constantly changing in a circular manner. So you have something like this. You have something that's like this, something like it's just rotating. I don't know if I get it now. So it's not in one direction, it's just rotating in a circular manner. And then that is what is going to produce circularly polarized light. And I've told you how that quarter wave plate is to convert from linear to circular and then back vice versa. And then for half wave plate, you have the right to the left-handed and vice versa. Now we have ORD and CD. ORD is optical rotatory dispersion, which is in linearly polarized light, and we have CD, which is circular dichroism, which is in circularly polarized light. Now you see, ORD is based on dispersion. It is a dispersive type of feature. Optical rotatory dispersion tells you that it's dispersive. It works based on dispersion. What it simply means there is that the linearly polarized light is dispersed on contact with the particular matter that is being talked about there. While for CD, circularly dichroism, it works based on absorption. So it absorbs left-handed and right-handed light based on its own specific characteristics, like the matter that is involved in circular dichroism absorbs the left-handed or the right-handed in different degrees, and that absorption is what is going to help you to understand circular dichroism. If you look into these two things deeply, you see how circularly polarized light in circular dichroism works on absorption, while ORD in linearly polarized light works based on dispersion. Deeper analysis can help you to understand that much more better, but we've talked about the types. Now the last of the list of the types of polarized light we have there is elliptically polarized light. Now elliptically polarized light consists of two perpendicular components of the electric vector of unequal amplitude which differ in phase by 90 degrees. Now you already know that this is a cycle. This is a cycle, and then when you have a cycle that is not really all that perfect, it can actually looks almost like an ellipse. It can look like an ellipse. So some sides have a longer diameter than the other type and all of that. So what we have in circular is moving in the same direction, everything is equal, but yeah, it is not working, the differ is unequal amplitude and it differ in phase by 90 degrees Celsius. So the kind of rotation is going to produce is an elliptical kind of rotation, unlike the circle that produces circular rotation. And that elliptically polarized light also has the right-handed elliptically polarized light and the left-handed elliptically polarized light. But the interesting thing about it is that you can only convert linear polarized light to circular polarized light. You cannot convert it to elliptical polarized light. I mean, as at the time of this particular tutorial, there's nothing has been discovered as to how to convert linearly polarized light into elliptically polarized light. Another thing again you need to notice is that circularly and elliptically have both left-handed and right-handed, but linear does not have anything like left-handed or right-handed. It is just a single direction and it goes that way. Then the elliptically polarized light usually find its application in satellites, communications, and the like. That is where you find the usefulness of elliptically polarized light. So now we are done with the types of polarized light. We are going to go into optical activity, look at measurements using polarimeter, and then we'll solve one or two things under that.